Ladies and gentlemen, our next session is about to begin. May I request you to kindly mute your microphones and wait as we prepare for the session. Thank you.
Good morning, everyone. Welcome to the RB Memorial Conference on Translational Research in Medicine, TRIM 2022. Welcome to Track-5 Digital Health. Digital health is a multidisciplinary concept which aims to provide improved and cost-effective medical services through the intersection of medical technology and healthcare. It applies digital transformation to the healthcare field, incorporating engineering and technology, management and services. This track is going to feature three eminent speakers, Dr. Sudeep Gupta, Mr. Girish Raghvan, and Dr. C.S. Pramesh. Let me thank all the speakers for accepting our invitation and to grace this occasion. Let me now request Professor Ganesh Ramakrishnan, Professor in charge of KCDH IIT Bombay, to convene this session. Good luck everyone for Track 5 Digital Health.
Improving healthcare is a key priority for all countries in the world, including digital health has proven to be a very effective tool in improving quality, access, and cost of healthcare. Consequently, digital health is one of the fastest growth areas in technology. India too is investing heavily in digital health technology. The government is rolling out the Ayushman Bharat digital mission across India, which will drive new healthcare solutions, similar to the impact of Aadhaar and UPI on financial solutions.
Digital health, it has substantial benefits for healthcare and its stakeholders, patients, hospitals, government organizations, doctors. We're really excited to support IIT Bombay in setting up the Center for Digital Health.
Koita Center for Digital Health, or KCDH, drives research, entrepreneurship, and employment in digital health.
The center is the first of its kind in India, and our vision is to establish KCDH as a globally renowned center in digital health and digital health informatics.
KCDH is proud to have a world-class advisory board with renowned members from diverse backgrounds, including directors of renowned hospitals, professors from top universities, and the senior executive of leading health tech firms.
We offer world-class academic programs in healthcare informatics, and we groom an exceptional cadre of students. Our students work on exceptionally good projects through internships and placements at some of the best companies in digital health.
The center offers a wide range of courses in computer science, AI and machine learning, medical imaging, healthcare data management, healthcare economics, and healthcare ethics. These courses are taught not just by IIT faculty, but by faculty visiting from various leading hospitals and research institutes.
Partnering with expert clinical professionals, that's our key priority area. The center is actively involved in applied research development activities and facilitates collaborations between engineers, clinicians to solve real-world healthcare challenges with access to clinical data and expertise.
We are establishing collaborations with leading hospitals, healthcare organizations, and healthcare regulators to drive collaborations in research and teaching programs, funding, and policy. The center is committed to providing meaningful internship and career opportunities for our students.
Digital healthcare is poised for a massive transformation in India. We are excited that the center can contribute to accelerating digital health adoption in India, which in turn will positively impact healthcare outcomes. We invite you all to join us and be part of our center.
Ladies and gentlemen, our next session is about to begin. May I request you to kindly mute your microphones and wait as we prepare for the session. Thank you. Ladies and gentlemen, join me in welcoming Professor Sudeep Gupta from Track-5-Digital, Mumbai. Dr. Sudeep Gupta is a professor in medical oncology at Tata Memorial Hospital in Mumbai, India. Dr. Gupta obtained his MBBS degree from All India Institute of Medical Sciences, New Delhi in the year 1992. Thereafter, he completed his postgraduate degree in internal medicine in 1994. Following his medical oncology training in the year 2000, Dr. Gupta joined Tata Memorial Hospital in Mumbai as an assistant professor in medical oncology and was promoted to associate professor in 2003 and professor in 2010. Dr. Gupta has been the primary author and collaborator of over 60 peer-reviewed publications in national and international journals. Currently, he is the editor-in-chief of Indian Journal of Medical and Pediatric Oncology and the General Secretary of Women's Cancer Initiative. He has been an invited speaker and expert panelist on cancer at many international, regional, and national congresses. Please welcome Professor Sudeep Gupta from Track-5-Digital, Mumbai.
Good morning.
Now I request to Professor Shivli to proceed this session. Thank you. Over to you.
Hi, hello everyone. I am Shivli Mukhopadhyay from Department of Mathematics at IIT Bombay. I will be chairing this morning session in
You're not audible.
I'm not audible. Just a minute. Let me get the...
She's audible. I can hear her well.
She's audible. Yeah, I can also.
Yeah.
Oh, okay. Okay, so I'll be chairing this morning session in Track-5-Digital Health. Now I would like to invite Dr. Sudeep Gupta for his talk. So Dr. Gupta, you have 30 minutes for your talk, and then we'll follow it up with 5 to 10 minutes of questions and answers. So over to Dr. Gupta. Thank you.
So good morning, colleagues, and thank you very much for inviting me to the session today. Let me share my screen and then, okay. Are you able to see my screen?
Yes, yes.
Okay, perfect. So thank you very much for inviting me to this conference. in the memory of an outstanding scientist. So therefore, it is with a tinge of some sadness that I deliver this talk, but she continues to inspire us. And I would also like to thank the Koita Center for Digital Health and IIT Bombay for the opportunity. I must add that I'm no longer the editor-in-chief of the journal that was mentioned in my introduction. That was several years ago, and a few other things have changed since then, but here I am. So what I will do is, in the next 30 minutes, I will share a few ideas related to digital health that have been incubated by my colleagues at Tata Memorial Center and ACTREC. A disclaimer is in order. I'm no expert on digital health. I'm a physician. I specialize in the treatment of breast and gynecological cancers. I also do a bit of translational research. And so most of the ideas that I will present today have been led by several of my colleagues from my institution. So this is a cartoon that depicts the growth of the world's population. And although it is hard to believe, but the population of the world until the year 1900 was only about 1 billion, and it has increased almost 8-fold in the past 100 years. The reason, and most of this increase has been in the developing countries. And the reason why this is important is because individuals aged older than 65 years or the older population has also significantly increased in the past many decades, and mostly confined to the less developed parts of the world. The reason this is important is because many non-communicable diseases, including cancer, are diseases of aging. And what this means is that we are bound to see a higher incidence as well as burden of diseases like cardiovascular, cancer, and other non-communicable diseases. This is the mortality and incidence of cancer as of 2020 in Europe. And you can see that the overall incidence was about 320 to 360 per 100,000 population. This is the number of new cases. And the mortality was about 1/4 to 1/3 of the incidence. In countries like India, the incidence is much lower. You can see that it is about 100 to 150, but the mortality as a proportion of our incidence is much higher, about 50 to 60%. And this, of course, is a reflection of the state of healthcare in many countries like India. And we do have a long way before we can achieve the kind of mortality and cures that are prevalent in other parts of the world. So this is the burden of cancers. You can see that currently in India, we have about 1.3 million new cases of cancer every year. This is projected to increase to about 2.1 million in the next 20 years. In terms of deaths, 850,000 deaths annually due to cancer at present, projected to increase to about 1.4 million in the next 20 years. This is a map of the world by the number of radiotherapy machines per million population, and you can see that parts of the world, including India, that have the highest incidence of locally advanced cancers which require radiation, have some of the least developed infrastructure with respect to not only radiotherapy but other treatments as well. Of course, we are getting better last few years, and hopefully the situation will improve in the coming few decades. In terms of the human resource that is available, also we are quite deficient. And I say all of this as a prelude to a talk on digital health is because a few activities and initiatives in digital health can actually mitigate the deficiencies both in infrastructure as well as in human resource. On the plus side, because of the robust generic pharmaceutical industry, the cost of medications, including cancer medications, is some of the lowest in the world in India. and which is why we are also called the pharmacy of the world. And until about a couple of decades ago, this used to be only Tata Memorial Hospital in Parel. In Navi Mumbai, we have Varanasi, we have Guwahati, we have Mullapur and Sangrur in Punjab, Muzaffarpur in Bihar. We are at and Vishakhapatnam, so we are at several locations all over India. The mission of our institution is to provide comprehensive cancer care to everyone, regardless of their ability to pay for it, through excellence in service, research and education. In terms of the number of new cancer cases that we register, we would be among the largest cancer institutions in the world, if not the largest. And you can see that most of the patients come from within Maharashtra and from north and northeast parts of India, again pointing to some of the inequities in healthcare that are prevalent in our country in terms of the geographic spread. At Tata Memorial Center, we have pioneered, at least in India, the concept of disease management groups. So individuals from several specialities such as surgery, medical oncology, radiation, pathology, radiology, etc. They come together to form a group of multidisciplinary individuals who deliver care to patients in a coordinated manner. So for example, although I am a medical oncologist, my primary identity is as a physician who specializes in the treatment of only breast and gynecological cancers. And this has enabled our institution to achieve higher levels of expertise and excellence in each of these areas. We have what we call the hospital information system, and this has several modules that are listed here on the left. And we have been more or less paperless in our clinical operations for the past several years. And many of you will immediately realize that this lends itself to some ideas in digital health. Image management system, we have had essentially filmless operations for the past 15 years. All the radiology and nuclear medicine images are available online, with a few other medical images available as well. And again, this lends itself to some ideas in digital health. So let me give you a flavor of the clinical research that we do at TMC, and I will not take you through the entire gamut, but point out the few ideas that have lent themselves to some innovation utilizing the concepts of digital health. So we have a robust clinical research system. We have 3 ethics committees at Mumbai and at least 1 ethics committees for each of our other hospitals. We have the research secretariat, clinical trial center, data monitoring committees. Everything is overseen by what we call the TMC Research Administration Council. Let me give you a few examples of the kind of research that we do. So, you know that cervix cancer is one of the most common cancers in women in India, the second commonest after breast cancer. A long-standing question in this disease has been the relative value of radiotherapy versus surgery in the treatment of patients with locally advanced cancer. So should you treat patients with chemotherapy and surgery or chemotherapy and radiotherapy? And we conducted a randomized controlled trial comparing these two strategies, neoadjuvant chemotherapy followed by surgery versus chemoradiation. And I had the privilege of presenting this at the plenary session of the ESMO Congress in 2017, subsequently published in the Journal of Clinical Oncology. And our group showed that radiotherapy with chemotherapy resulted in measurably and clinically significant improvement in disease-free survival by almost 7 percentage points. But the thing was that although it resulted in a higher cure rate, the toxicity to the organs that surround the cervix, the rectum, the bladder, vagina in terms of sexual health, in all of those toxicities, in the medium and long term, radiotherapy had a resulted in a higher level of toxicities compared with surgery. So it was led by my colleague Dr. Supriya Chopra and several colleagues from the Gynae DMG group. And this compared intensity modulated radiotherapy, image guided, which is a form of very focused kind of radiotherapy, very expensive, but nevertheless a good way to deliver radiation. And the idea that we tested was whether this resulted in a lower incidence of toxicity to the surrounding organs, mainly the GI tract. And actually, this was presented only a couple of years ago and then published last year in JCO. And we showed that intensity modulated radiotherapy did result in a reduction in GI toxicity compared with conventional radiotherapy. Now, the point is that although it did result in lower grades of toxicity, as you can see here, it requires significant amount of physicist and physician time. Here it is 4 hours compared with the conventional radiotherapy that requires only about 30 to 45 minutes for planning. And the same is true for brachytherapy, which is a form of intracavitary radiotherapy for cervix cancer. Again, requires almost 2 hours of planning for a single patient compared with much lesser times with conventional techniques. So our gynec group, led by Dr. Supriya Chopra and Dr. Jamema Swamidas, who's from the medical physics department, they tried to see whether automated high precision planning could be undertaken in order to reduce the time that is required by physicians and physicists for planning of each treatment. And so they published this paper on knowledge-based planning in 2019. What they did was to feed prior treatment plans called training plans for hundreds of patients into the system, and information on many variables such as a structure set, dose, field geometry, etc. were extracted and then fed into the model. And using a combination of principal component analysis and regression techniques, they created what is called a dose volume histogram model, which then predicts the amount of dose that each organ will receive for any particular patient based on the variables that are fed into based on the patient variables that are fed into this automated plan. This was the paper that was published. The automated plan was at least equal to, and in some instances for some organs, significantly better in terms of dose to the surrounding organs compared with the human plan. And this was the internal validation of this automated system. This was then externally validated in collaboration with Danish and Canadian colleagues. And you can see that in every single instance, the machine generated plans were better than the human plans in terms of dose to the surrounding organs. And you will also note here that the total amount of planning time for the automated plan is only about 45 minutes compared with almost 4 hours of physicist and physician time that is required for human planning. So this particular plan was configured on a variant platform, and this will now be available worldwide to all physicians as a choice for planning their patients when they are treating cervix cancer, including the regional lymph nodes. The same automation is also being undertaken for brachytherapy planning. This is a project that is funded by the DST in collaboration with our colleagues from Europe. You can see that automated brachytherapy planning is also being undertaken, and the actual time is almost 1 hour for humans versus only about 1 minute for the automated plan. Not only be relevant to cervix cancer, but to several other cancers that require radiotherapy to the pelvis. And I show you the results of a very important trial that was just published by my colleague Vedang Murthy and colleagues from the genitourinary group, which showed that whole pelvis radiotherapy resulted in much higher cure rates in patients with prostate cancer. So let me come to breast cancer. Treatments may be effective, but they are useless unless the patients have access to those treatments. And this was in the year 2005. Hortobagi, writing in the New England Journal of Medicine, said that 1 year of a drug called trastuzumab, which is a HER2 targeted therapy, is revolutionary. And we audited our patients in 2008, and we found that only about 8.5% of our patients had access to this drug because of costs. The cost of treatment being close to 1.2 lakhs of rupees every 3 weeks for almost a year. We did a few in 8 years, the access improved to close to 60%, and it is close to about 95 to 100% now. And what did we do? We did a number of things, including social partnerships, philanthropic support, lower cost biosimilars, etc. But one thing that we consistently advocated based on the results of earlier only a few studies was to use shorter durations of adjuvant treatment with trastuzumab compared to its full 1 year course. But the question that has a very important question that had not been answered definitively was whether shorter durations of trastuzumab can lead to an acceptable outcome and equivalent outcomes compared to its 1 year use. There are 6 randomized trials that have compared shorter durations ranging from 3 months to 6 months compared with 1 year, but only one of them has reported non-inferiority. So what did we do? Pioneered conducting an individual patient data meta-analysis. The usual way of doing it is to write to all the principal investigators, get all their Excel sheets and data, and then combine the data. What we did was to extract individual time events from the published survival curves using a software called the web plot digitizer. And then we used Stata IPDFC command to actually construct the IPD meta-analysis, literally an IPD meta-analysis only from data that was extracted from published survival curves. And I show you this slide only to give you a sense of the exquisite accuracy with which we were able to reconstruct the survival curves. The curve on the right is a reconstructed curve that we constructed by extracting individual time events from the published curves. All the data, and we showed that 3 to 6 months of trastuzumab is actually non-inferior to its 1 year use. Now 3 to 6 months is about 1/4 as expensive as its 1 year use, and this result has been adopted by the Ayushman Bharat, and we have contributed to a cost-effective treatment that is applicable to more than half the world and extends the benefit of this treatment to many, many more patients. This is a study that was led by my colleague Shalaka Joshi. This is an online self-administered decision aid to reduce the decisional conflict in women undergoing surgery for breast cancer. So many of you know that when a woman presents with breast cancer, there are 2 choices for surgery. One is conserving the breast, the other one is mastectomy. And there are some trade-offs, the main trade-offs being that breast conservation leads to a better cosmesis and other aspects such as self-esteem, psychological functioning, etc., and so on. But the flip side is that every woman with breast conservation does require mandatory post-operative radiotherapy. So this is a difficult decision, and it is difficult to convey all the nuances of the pros and cons to every single patient in the clinic. So what was done in this particular study was to use an online aid, and this was done in collaboration with some colleagues from the Harvard. You can see that this is the decision aid conveying various aspects of the 2 surgical treatment. and then the patients are administered a questionnaire to measure their decisional conflict regarding mastectomy versus breast conservation. And this is the questionnaire that is used to measure the decisional conflict. So the hypothesis was that administration of a structured online decision aid will reduce the decisional conflict regarding the use of mastectomy versus breast conservation. The patients were randomized to 3 arms. The first arm, they underwent usual care, no decision aid. In the second group, only the woman was shown the decisional aid. And in the third one, it was the woman along with a key male partner who were administered the decision aid. And you can see that the decisional conflict was significantly groups which were administered the online decision aid, which is called the Navya PPT. This study has been presented at the San Antonio Breast Cancer Symposium as well as ASCO and is currently under publication. And it is ideally suited to many countries and practices like India, and it can be delivered in vernacular languages and can significantly impact the decision-making ability of our patients. This is a recent viewpoint that I took from the Lancet Digital Health, Data Poverty, and I will quote, "We assert that health data poverty is a threat to global health, which could prevent the benefits of data-driven health technologies from being more widely realized and might even lead to them causing harm. We argue that the time to act is now to avoid creating a digital health divide that exacerbates existing health inequalities and to ensure that no one is left behind in the digital era." So our own contribution towards reducing data poverty in terms of the cancer scenario in India is this particular project that has been funded by the Department of Biotechnology. This is in collaboration between TMC, IIT Bombay, and I saw Dr. Amit Sethi. He's our main collaborator from IIT Bombay, AIMS, PGI, and Rajiv Gandhi Hospital in Delhi. And the is to build a database of cancer radiology and pathology images linked to their clinical information, and to annotate the images and make the annotations available as part of the database. And subsequently, this will be available to everyone to drive AI-based algorithm development using the biobank infrastructure. You can see that this will be both pathology and radiology images with relatively granular level clinical information. A minimum data set has been defined, and many of you know that cancer is a longitudinal disease. It's not a cross-sectional disease, and therefore it is very important to also collect longitudinal information and store it as part of this imaging biobank, which we are doing. In 2 cancers, head and neck and lung, significant progress has been made, but we have been approved for banking the images and linked information of almost 50,000 patients by our ethics committee, which is in progress at the current time. The viewers and annotation platforms have been finalized and deployed. There is a detailed multi-level annotation, including cross-checking by at least 2 pathologists and radiologists in each case. And this is the kind of annotation that will be available. So I'm showing you this because this data bank will take some doing to build. It is being built even as we speak now, and hopefully this will be a resource for everyone to utilize in the future. This study has been shared very kindly by my colleague, Dr. Swapnil Rane. We know that pathology reports are the single most important input in cancer treatment, but they have traditionally been either handwritten or typewritten or typed as a narrative report, which is nice and intuitive, but also doesn't lend itself to archival, retrieval, and digital health activities as much as a synoptic kind of reports that we used to give out, and not until not very recently. So the worldwide push has been to change these narrative reports into increasingly sophisticated synoptic reports. And the level 6 essentially is reports that also incorporate standardized terminologies like the SNOMED, ICD, etc., and so on. And we have implemented this in a phased manner in Tata Memorial Center. So my colleagues actually did this analysis to see whether synoptic reporting has helped. There is a lot of resistance to every change in every institution. And so these are several parameters that pathologists should report on pathology. And you can see the last bar in each of these figures is actually the synoptic module. So the completeness of reporting has significantly improved with the adoption of synoptic module, including several features that should be routinely reported by all pathologists. And what is better, the turnaround time is actually less with synoptic reporting. So this will lend itself to this can lend itself to digital health initiatives of many kinds. This is the last example of a digital health initiative that I will share with you. I'm the principal
Sorry to interrupt, Dr. Gupta.
Yes.
You have 3 more minutes. Yeah.
Okay, perfect. I'm towards the end of my slides.
Okay.
So we aim to look at the occurrence and frequencies of comorbidities such as hypertension and diabetes in our patients. Now, you know that hypertension, diabetes, hypothyroidism, etc. can be written in a variety of ways on the EMR. So we have all these sources for extracting data on comorbidities. We will extract the relevant medical entities from the existing EMR data using an ETL framework, OCR pipeline, and natural language processing engines. This data will be transformed into standard common data models and then will be loaded onto the relevant CDM framework. And this is in 30,000 patients. This is a proof of concept study. If we are able to do this, we can build a common data model from relatively unstructured EMR and other data for a variety of conditions. So this number of publications from Tata Memorial Center in the field of AI and digital health. I do not need to go into the details of each one of them. What does the future hold? All of us think that digital health, artificial intelligence, and related themes have already arrived. This is a meta-analysis of the comparison of deep learning against healthcare professionals in reading radiology images. Analysis, the deep learning models achieved equivalent levels of diagnostic accuracy. A more recent meta-analysis on mammograms, and you can see that the false positive rates by the AI algorithm is much higher than human readers. And despite all the hype and hoopla, the conclusion, at least of this particular analysis, is that current evidence in breast cancer screening is of insufficient quality and quantity for implementation into clinical practice. The reason why I show this is because there is a lot of work to do to enable the fruits and the benefits of digital health to actually reach clinical. This is a slide that has been shared by Dr. Swapnil Rane. This essentially suggests, I'll not go into the details, this essentially suggests that digital health and artificial intelligence algorithms are likely to complement humans rather than supplant them. I'm done, Dr. Mukhopadhyay.
Thank you, Dr. Gupta, for a very interesting and informative talk. We'll go to the questions. So there are some questions already typed up in the chat box. The first is by Professor Amit Sethi. So Amit, would you like to ask your question?
Sure, thank you. Dr. Gupta, how much of the low incidence of cancers in low and medium income countries can be attributed to underdetection and underreporting?
Maybe only a small proportion, at least in India, because aside from everything else, India has a long-standing history of having a very robust cancer registration system. We have several population-based cancer registries run by the ICMR that are of high quality, at least with respect to incidence, maybe not for mortality. and so the numbers for India are fairly accurate. There may be a little bit of under detection, but for the most part, these are the real numbers.
Thank you.
This may not necessarily be true of many other countries, but in India, we have a very nice registration system for cancers.
So the next question is by Professor Ganesh Ramakrishnan. Ganesh, could you ask your question?
Yeah. Dr. Sudeep Gupta, thanks for an excellent and comprehensive presentation. You talked about the online decision aid. So what were the modality choices for the questionnaire? Like, did you do audio and text? And if it was audio, we have faced a lot of problem with accent, right? So how did you get the patients to seamlessly, enter their preferences, their feedback?
So the way this was done, so one limitation of the study was that this only the patients who were literate enough to read the slides and the information were only included, and illiterate, I mean, this was not for illiterate patients. So the way this was done was patients were administered the decision aid in a language that they could read. This was not an audio, this was reading. They went through the PowerPoint presentation, they clicked and the next. And at the end of the decision aid, they filled out a research questionnaire which could measure the decisional conflict regarding the two types of surgeries. So you are right that this did require patients to be literate enough to read the decision aid, the information in the decision aid.
Thanks. And a very quick question, the CAIB will also include PET CT scans. I probably missed that.
Yes, it will include radiology and radiology of all kinds, mammograms, MRI, PET CT scans, as well as pathology images. So the radiology is fairly straightforward because we have a PACS and the DICOM format has already been in existence for a long time. Pathology is a little more challenging because an image archival methodology that is accepted by everybody worldwide does not exist in pathology, and for the most part pathology is still the physical slides under the microscope rather than digital pathology.
Thanks.
So are there any more questions? If not, then we will move on to the next talk by Mr. Girish Raghvan. Thank you, Dr. Gupta.
Can you hear me?
Yes.
Yeah, just a moment, please. Sorry for the interruption.
Sure.
Is my screen visible?
Yes.
Yes.
Okay, thank you. Is the sound coming or not?
No, there is no sound. There is no sound.
There is no sound. Oh, let me share again. Hopefully it will come now. What about now?
No, there is no sound. So should I introduce him without the video?
Let me check. Give me a last try.
Okay.
Ladies and gentlemen, our next.
Yes.
Ladies and gentlemen, our next session is about to begin. May I request you to kindly mute your microphones and wait as we prepare for the session. Thank you.
Ladies and gentlemen, please join me in welcoming Mr. Girish Raghvan, who joins us from GE Healthcare. Currently, Mr. Girish is the Vice President of Digital Platforms and Engineering and GE Healthcare India Technology Center. He has completed his Master's in Business Administration from Bharatiya University. Currently, he leads the Global Engineering for Edison Platform, a strategic project for GE Healthcare. He also leads the technology mandate for GE Healthcare in India and South Asia. His role includes interaction with key clients, partners, academia, and trade bodies. He has served in multiple engineering and technology leadership roles in GE for over 20 years across software, hardware, systems, service, and digital engineering departments. Ladies and gentlemen, please join me in welcoming Mr. Girish Raghvan.
Hi, Mr. Girish Raghvan. So I would now like to invite you for your talk. So Mr. Girish, you have 30 minutes for your talk, followed by 5 to 10 minutes of questions and answers. So over to Mr. Girish.
Okay, so thank you so much for the introduction. And before I start, I would really like to thank KCDH as well as IIT Bombay for firstly inviting me for this presentation and giving me an opportunity. I can clearly see that KCDH and IIT Bombay is doing some phenomenal work in this space. So firstly, congratulations to this team. So what I will do in the next 30 minutes or so, I would give you an industry perspective. If you look at the sessions for the last few, what has been planned and what happened just before, are more from a clinical perspective as well as from research perspective, right? So I'm just going to give you a market view. It's more of an outside-in perspective of how the market is evolving, what's happening, what are the big trends we are seeing in the industry. So I have five pages, which should be good enough. So let me share my screen and let me know once you can see my screen. Do you see my screen?
Yes.
So the topic of my discussion today is about the healthcare market themes, especially in the space of digital, the challenges we are facing, and the big trends we are seeing in the industry. So I would like to probably start with the key themes in the healthcare market today. So broadly, if you look at pretty much all the healthcare companies in India and maybe in this planet are focusing on four key themes. One is access and capacity. So every year we have around 160 million people in the world who come from poverty to middle class, and with that comes the propensity to pay, right? But today, unfortunately, our healthcare systems are not elastic enough to accommodate this 160 million who are coming on. That's exactly why you see huge queues in hospitals and this tier 1, tier 2, urban versus rural imbalances is all coming to access and capacity, right? So that's a very pertinent problem the industry is facing today. Second is waste, right? There's a lot of productivity waste in the healthcare system today. It is said that 20% of the healthcare expenses in OECD countries are all waste, right? It is just waste because you do a lot of overtreatment, misdiagnosis, and so on and so forth, right? The third big theme which the industry is grappling with is about the technology, the expertise required. So we have the number of the experts we have today in the industry is very limited. So as a consequence, you find that a lot of physicians go through significant professional burnouts. This could be, could be radiologists, could be a doctor, could be a nurse, could be anybody in the healthcare ecosystem. They go through tremendous amount of pressure. I don't know how many of you even realized that COVID time was something which people saw it at face value, but there's been always significant burnouts in this segment. So there are two issues here. One is there are less experts. As a consequence, they get burned out. Second is that there are less people who can have the level of expertise what is required either, right? So as a consequence, the whole system is very complex. The last one is clinical outcomes, right? So as most of you know, right, medical errors is the third largest cause of death in the US. After cardiovascular and oncology, right? This is the third largest one. It's around 10-ish% is what is medical errors contributing. And again, medical errors is because of same thing, right? If you go to a hospital and see, a radiologist would be going through some 100 X-rays or 100 CT scans in a day, right? He probably spends 2 to 3 minutes on a report. And when he does continuously from morning to evening, right, you're bound to make some errors as we go forward, right? I know of cases where people would have missed a small lesion in a PET scan, and 6 months later, when it becomes back really worse, you go back and look at the PET scan done 6 months back, and with a lot of multiple analysis, you find that there could have been somebody could have spotted it on much early on, right? So this is broadly the healthcare market themes and trends we are seeing today. And then coming to the challenges, right? Challenges are actually changed dramatically in the post-COVID world. Of course, right? There's a big ask of social distancing. So it is said that about 35% of all the interactions between a physician and the patient, the first interaction between physician and patient is going to be virtual. I don't think any of you here would even would have thought that a day would come in the pre-COVID era that you would have your appointment with the doctor virtually, right? Even my dad, who's 80 plus, right? He's very comfortable to get on a video call, on a WhatsApp video call with a doctor and get his consultation done, which is something I could have never thought of in the pre-COVID world. So social distancing is also driving that kind of behavior where doctors are asking folks to try to log in remotely. And now COVID is waning down. You'll find that the same trend is going to continue. The second challenge we are facing today is there's a lot of distributed points of care. So if you look at, we have all these big hospitals like we have an outsourced lab. If you look at the apartment where I live, right? So Apollo has set up I would say an outpost in my apartment. So people in my apartment who want to get a basic blood test done or wants to have a very basic consultation, and they don't go to the big hospital. They go to the small clinic which has been established in my apartment for all their day-to-day work. So that is becoming a norm today. So outpatient imaging centers, outsourced labs, shared ICUs. So there's basically two big trends over here: distributed points of care, like the one I explained, and then virtualization of care as well, right? So that is the second trend. The third big challenge we're facing today in the healthcare segment is with everything becoming virtual. You have virtual visits, like the one example I mentioned to you. You have a lot of work happening on remote patient monitoring, which is a very important area, especially if you look at today in large hospitals, there's an acute shortage of beds. So if you have a 1,000-bedded hospital, 500-bedded hospital, there are people waiting to occupy the same beds. And just because the doctors cannot monitor the patient, they have the patient to stay in the hospital for a long period of time. So I know one of the folks I have been interacting with, he had a stroke. He went to a leading hospital. It took him 4 days and he was fine. But the doctor asked him to stay for 3 more days extra, just because he said that he has no way of monitoring this patient. So just imagine the consequence, right? The patient is in the hospital for no reason. The expense goes up. He gets frustrated being in hospital because going back would probably make him feel much better. There are probably 10 patients waiting for the same bed. So the whole philosophy of remote patient monitoring, which is gaining a lot of traction today, is very compelling, because through remote patient monitoring, the patient can go back home, and the doctor sitting at a central location can keep monitoring the data coming from all these patients and then take actions as required. So remote patient monitoring, remote radiology reading is a challenge today as well. So today, with less and less radiologists we have today in the industry today in hospitals, we have one radiologist taking care of 5 or 6 hospitals in some cases, and he cannot travel to all the hospitals in a given day. So assuming that he's sitting in a remote place, and then he can remotely monitor all the hospitals, what is available in his purview, is going to significantly improve his productivity. So from a challenge perspective, this is the reality today, right? The healthcare delivery system has significantly transformed in the last couple of years through virtualization of care, to distributed points of care, virtual visit, remote patient monitoring, etc. And that is where the whole space of digital health is going to significantly make an impact. So if you look at some of the big trends we are seeing in the post-COVID world, so these are some of the top 8 trends which we collated from multiple journals and multiple, I would say, consultancy companies. But I would try to pick a couple of big things, right? One is obviously the whole focus on telehealth, telemedicine is going to become the new standard of care. As I was explaining in my previous presentation, so home diagnostics, remote monitoring, all these things are really going to be the norm, right? It is not going to be the COVID era. It is going to continue for in the days to come, in the years ahead as well. Okay, that is one big thing. Second, we are seeing hospitals financial distress and consolidation. It happened in the last couple of years. It's going to continue in the next few years as well, right? Hospitals are facing significant financial stress today. Is because of multiple things, right? Because the hospitals traditionally are running with low margins. So we are going to see significant amount of hospitals getting consolidated over the years to come, right? That's going to become the norm. There's a strong increase in demand for AI, especially as a decision support system. And this is very important for us, right? If the example what I was referring to earlier, if you take the life of a radiologist, he logs into his system at 10 a.m. in the morning. He would perhaps go through some 100 CT scans or 100 X-rays in a day. Just I'm assuming that we use good AI technologies where the AI system can pass through the entire 100 reports what he has got and is able to boil up the ones where he's seeing a potential issue that is going to increase the productivity significantly, right? So we have solutions today in the market where using artificial intelligence, we're able to look at tons of CTs and MRs and X-ray systems, and be able to boil up the ones which have a problem. So typically the guy would spend his most productive time looking at those abnormal scans, and he would spend the other after lunchtime perhaps, right, looking at the reports which are potentially normal, right? Is more about reporting and conclusion. So if you look at a typical CT X-ray, out of 100 X-rays you do, maybe 90% of them are normal. Only 10% needs the attention what is required. So we are seeing an increased demand in AI across the healthcare segment, and that is going to continue as well. It's more towards decision support systems. We are also seeing a lot of partnership with medtech and pharma. You would have seen in the news multiple times in the last couple of years. Lot of traditionally medtech and pharma were two separate segments. Pharma was a large black box. Okay, medtech has a lot of data with them. Like you have CTs and MRs and etc. The data is very crucial. Thanks to COVID, typically when a vaccine takes 10 years to develop and mature and evolve, in the COVID phase, it has to get compressed in a couple of years, right? And they need a lot of data to make this happen. So the partnership within medtech and pharma is going to be significantly helpful in making sure that we're able to take healthcare much faster as we go forward. Then with all this virtual care, remote monitoring, etc., there's a lot of concern on cybersecurity. So we're going to see a lot of traction on cybersecurity as this whole space of telehealth is going to expand. So there's a lot of focus from companies like GE Healthcare, and I'm sure with every company today working in the healthcare space on how do we strengthen cybersecurity to make sure we don't have data loss, we don't have privacy issues, that the systems are not getting compromised and so on and so forth. So that is definitely going to continue as a trend. The other big trend we are going to see in the post-COVID world is also about interoperability, right? So look at the previous page where I explained about a remote radiologist sitting at home and looking after 10 different hospitals, right, in a city. It is impossible for him to expect that all the 10 hospitals would have the same IT systems what we have. So it's possible that each of the 10 hospitals have their own IT systems, they have their own viewers, they have their own systems, they have their own cyber security, etc., right? So this whole question of interoperability becomes all the more important because you need systems to work with each other much closely than ever, right? If you want to really build a very vibrant ecosystem. And lastly, the regulatory framework is going to become extremely crucial. Reimbursements have to be as to change. I've seen the regulatory bodies across the globe have actually become more flexible in terms of taking into account the virtual services which are getting provided, which is a good news. At the same time, the reimbursement models also we are seeing a lot of changes happening globally to take into account the new trends we are seeing today in the industry. So these are some of the large trends, I would say, which we are seeing today in the healthcare segment, and this will going to continue in the post-COVID world as well. coming to what GE Healthcare is doing, right? I just want to have a couple of pages to talk specifically about GE Healthcare. So GE Healthcare is actually trying to make the system smarter. To some extent, it is, I would say, more like Tesla, I would say. So if you look at the auto industry, we're going towards driverless cars and so on and so forth. I don't think we'll get there in healthcare in even the near future. But what we are trying to do is we are using AI kind of technologies and deep learning kind of technologies to help to predict much faster. So to give an example, right, we are trying to make the CT, the example what I have here, right, we're trying to make a CT or an MR smarter as we go forward. So the idea here is that we will have AI systems inbuilt in these products. So the systems are smart enough that it can tell the operator what to do. So if you look at the traditional interaction between an operator and the equipment, the operator would tell the equipment what to do, and the equipment would do exactly what the operator tells. The assumption here is that the equipment is dumb, right? In the systems, what we are doing in GE, which we have released today, the system is so smart, the system would tell the operator what to do, right? So for example, it's possible, today we have systems which we have released where the CT system, when you have a patient on the table, the CT system would go back and look at the hospital information system, will look at the EMR records, will look at the radiology records, etc., and would recommend to the operator, look, I've seen this patient is obese, this patient has these histories. And for this patient, I would recommend that you use one of the 3 protocols what you have, right? So the technologists can go and choose the right protocol, so which is optimal in terms of dose, which will give the right image quality for the radiologist, right? If you look at today or in the pre world, we used to have the technologists call up the radiologist. Okay, the radiologist might be busy in something else, right? And you have a patient on the table. So in more often than not, the technologist would use his guesswork, right, or his experience to get things done. Is very, I would say, very uneven in terms of the quality of images what you get. But technology like what I mentioned here is going to significantly help. So the idea here is to make the system smart enough. The system can tell the operator. So if you look at today, the GE systems can in fact tell the operator if the patient is moving, right? So if you look at some of these scans, if the patient moves too much, the image will be very distorted. So the system can go and tell the technician, look, I think the patient has moved too much. Maybe you want to do a rescan, right? So there's a lot of intelligence we are building the system to help the patient experience be much more smoother. At the same time, making sure the quality of care is significantly improved. And this is also more important, especially when we go to tier 2 or tier 3 cities, right? Especially in India, where we do not have adequate trained technologists or radiologists, where these systems would be able to help the technologist and the radiologist much more than ever, right? So the quality of care can be maintained as well. So to do this, to make the system smarter, obviously we need a lot of applications which are intelligent. So if you look at the examples I have mentioned here, some of the examples we have here, these are trying to make the application smarter. And to do this, we need data, right? So what we are doing in GE Healthcare is we have this what we call the Edison platform, which is part of the digital health portfolio what we have. So we actually provide developer services. So if you are a startup, right, or if you are a company who wants to build applications, we provide development kits which the company can leverage and build applications using the services what we provide. And they would make applications which are smarter and intelligent, which will sit on the device. So we provide the entire suite of applications through the digital health portfolio under Edison platform, using which a startup or a healthcare company or a healthcare provider can build applications which will bring good amount of intelligence into the system, which will, as a consequence, make the system smarter and efficient. So the whole focus here has been on how do we make the entire end-to-end workflow seamless and efficient. Okay, so this is at a high level some of the work we have been doing in the space of digital health. Now coming to why GE Healthcare is well positioned, right? So when you talk about digital health, obviously data plays a very important role. So from our perspective, what we have been doing is that so we have more than 4 million units worldwide today across imaging, mobile diagnostics, and monitoring. We are perhaps one of the few companies in the world which has got so much of systems installed globally, right? And we are present in 160 countries in the world. So obviously you have huge variation of data which you can get over a period of time, right? And we also have a lot of volume, right? As we speak, every minute somewhere in some part of the world, there are 16,000 images being generated on a GE healthcare equipment. And every year we do more than 2 billion scans on a GE equipment. So all this actually provides us the kind of experience required to build the kind of applications what we were referring to in the previous page. Okay, so that's at a high level some of the key topics which I had to share with you. But before I conclude the 30 minutes talk, I have a video for 5 minutes which I want to briefly put on screen. Let me know if you're able to hear me. Are you able to hear the volume?
Yes.
Okay. So this video actually talks about how digital health would be in the future. So as we go forward with all the technology innovations, what we are doing today, both in healthcare, GE healthcare, and also across the industry, you'll find that the technology is going towards this direction. This could be a quick glimpse of how imaging would look like in 2030 or 2040. Again, this is not something, it's not that GE is working on all these technologies, but some of these things are good indications to where the industry is going towards. Okay.
The world changes, but some things never change. Difficult moments can make time stand still, but love can make a lifetime pass in the blink of an eye. You said I'd understand that someday. And then I blinked. And you were gone. Alarm off.
Good morning, Sophie. How did you sleep?
You tell me, Oz.
447 minutes of confirmed sleep, 34.2% REM. Slept like a baby.
Increase floor temperature.
Increasing floor temperature.
And start me a slow drip, will you? I'm going to take a shower.
Of course, Sophie.
Mom, guess what? It's a girl.
I have scheduled for you an appointment at the microclinic. Your full medical history and self-exam results from this morning have been confirmed received. And your primary care doctor, Liz Childers, has been notified of your appointment.
Sophie, we've been expecting you. I'm Lily, your technologist. Let me show you to your personal pod.
Mom, where do I begin?
Our pods will help put you at ease. They're equipped with sensories.
I remember you telling me how you would sing to me before I was born.
It's going to be okay. Before we do any further testing, we're going to go over the results of your self-exam. But first, let's give you the sensory atmosphere you requested, shall we?
That you were convinced it was why I have such great taste in music.
Step up to the scanner and relax your body. Remain still. And 3, 2, 1. Good. Lift your arm above your head. Remain still. And 3, 2, 1. Good.
How the mere thought of me was all it took for love to grow stronger than anything you'd ever known. The invisible things that consume us. Love. The fear you had dealing with this, and how different it is for me today.
You look great. All right, now you're just going to lay down for me.
Facing the very same thing that took you from me. You told me once we can look so deeply into ourselves that we miss what's most important.
So I'm afraid the MRI does show a suspicious lesion in the left breast. Based on appearances and outputs from the artificial intelligence application, probability of malignancy is high. That's the not so good news. The good news is that we caught it early, and when we look at global
I've been
data,
thinking about that lately.
predict an excellent outcome for you.
But I see something now that was harder for you to see back
Talk
then.
about next steps.
Hope. Hope in the world that surrounds me, in the people here to guide me through. You told me it was something I'd find when I needed it most. And I have.
Sophie, you've got a really good team here. As I told you before, I think things are looking really good.
Oh. Hi, Mom. How's the news?
What I hoped for.
Oh. Look at her.
I just wish you could be here today to see it and to meet your great-granddaughter. She has your smile.
Everything is set for tomorrow's party, Sophie. GE believes in the power of emerging technologies to advance precision health and transform patient care. The outlook for healthcare has never been brighter.
So if you look at what I was trying to conclude with the video is that the potential for digital health and technology is very compelling as we go forward, right? Today we are at a very initial stage. Some of the examples I told you about intelligent protocoling or protocol management, and systems being intelligent enough to tell the technicians what to do, what not to do, etc., are actually at a very initial stage. Though they may look wow for us at this point in time, but what is ahead of us is very solid. Okay, so just gives a glimpse of the potential in front of us. So I know I'm already 30 minutes into the meeting, so I'll pause here and I'll open up for questions from the team.
Thank you, Mr. Girish, for a very interesting and informative talk about how GE Healthcare's technology innovations are helping Indian healthcare system, particularly in this difficult COVID times. Questions from the audience? Any questions?
I had posted a question. I can read that out, Girish.
Yeah. Sure.
So given privacy concerns, could you comment on, federated storage, federated management, also federated AI across the data that you said is lying with, medtech, pharma, as well as hospital data, right? And you talked about the Edison platform. So either through Edison platform or otherwise, have you been looking at federated learning? And I think this is all the more critical because, assuming the data interoperability and other concerns and sanity checking through your intelligent applications that you spoke about, all that is taken care of. We would eventually like to reduce the computational overhead as well as preserve privacy. Yeah. Any suggestions?
Oh, yeah, definitely. I think Ganesh is a good point. So we're doing some work around federated learning as well, big time. In fact, we are partnering with one of the companies in the US in this space. So again, the philosophy here is that the data stays wherever it is. See, hospitals have their own constraints as well because they don't. There are regulations at an hospital operating system level. There are regulations at a country level as well, right? Each country has got different regulations on data privacy and security. So the federated learning has been very helpful for us, Ganesh, right? We are working on some projects where we have the algorithm will go to the place where the data resides. It will execute on it and come back. So data would continue to stay where they are. So we are doing some work on federated learning. We're doing some work on security around that space as well. So this is definitely a very solid thing for us to work on.
Thanks, Girish, and thanks for a nice talk.
Any other questions from the audience?
I have a question. So are there any plans for introducing, let's say, new versions of the MRI and CT equipment that can be better adopted due to a lower price point in low and medium income countries?
Yeah, I think definitely. See, there is a lot of I would say misconception today, Amit, in the industry, right? That with AI, etc., cost is going to go up. In fact, it's on the contrary, right? Because what's going to happen is the cost of the hardware would come down dramatically, right? Especially when you have AI. See, for example, if you don't have AI, the kind of computational power you would need is going to be significantly higher. With using AI kind of technology, is going to come down. So definitely, we are going to see cost, not right in the short term, but at least in the midterm, cost would definitely come down. And then comes the power of cloud, right? So today, if you look at in current situation today, Amit, we have the computers, right, should be so high powered to work on the worst case situation, right? Today, the kind of work we're doing today in GE Healthcare, we use clouds very to an advantage, where we have the local computing happening at a nominal stage. But whenever there's a high computational need, you would leverage the cloud where you have elasticity available there. You can take more compute for a short period of time, right? So this kind of hybrid computing, which is still in its early stage today in a lot of industries, once you have the hybrid computing systems in place, right, it's going to definitely help in getting the cost much more lower. The third thing we're doing as a company is also, Amit, we're trying to make our system much more simpler. Like one example of the CT system what we released a couple of years back, right? So we actually reduced the number of clicks by 80%. Okay, so what happens is today, if you look at a high-end or an older CT system, you have so many buttons, right? It needs a level of competence at a much higher level to operate. It's like operating a aeroplane, right? You need so many buttons, and you know what to use, what not to use. So we have actually done a lot of workflow mapping. We work with some 250 clinicians in India, and we identified what are the basic things what are required, and we removed completely, and everything is behind the scene. We use software technologies to automate a lot of these things, which actually need not need an operational intervention. So as a consequence, we have found that the competence required to operate the systems have come down. The cost has definitely come down because you don't need all this kind of high-end computing. And then we are also finding that the quality of care also be much more normalized across the larger population.
Thank you.
Hi, this is Prasad here. I have a question.
Sure.
So just wanted to know, is there a way in which some of these systems in modular form or some way can be brought in, let's say, places like IIT Bombay, and researchers like Professor Amit Sethi, Professor Ganesh can use the data to refine the algorithms, etc., that they are working on?
Yeah. So right now we haven't opened it up, Dr. Prasad, at this point in time, but we have it in our planning. Okay, because we are actually working with a couple of IITs as well, and we've been talking to a couple of your colleagues as well on this. So eventually we will do that. So the Edison platform by itself, Prasad, is a very powerful platform what we have built. So this platform can be used by industries to build algorithms on top of that. So it is not subsets of the platform, but the entire platform by itself can be definitely provided. And we can talk about this for sure.
Okay, thank you.
So in fact, across the world, Dr. Prasad, there are a lot of, I would say, leading universities or academic institutions using the Edison platform precisely for this, right? So we have got in collaboration with some of the universities, and they're using a platform to use their AI models and train them and test them. So we are doing some work with a lot of institutions. So definitely we can look at that.
Okay, thank you. I'll get in touch with you.
Yeah.
Any more questions? Okay, thank you, Mr. Girish, for the talk. So we will move over to our last speaker, that is Dr. C.S. Pramesh. So now KCDH office will again play a short introductory video.
Ladies and gentlemen, our next session is about to begin. May I request you to kindly mute your microphones and wait as we prepare for the session. Thank you. Ladies and gentlemen, our next session is about to begin. May I request you to kindly mute your microphones and wait as we prepare for the session. Thank you. Ladies and gentlemen, please join me in welcoming Dr. C.S. Pramesh from Tata Memorial Hospital, Mumbai. Dr. Pramesh is the director of Tata Memorial Hospital and the professor and head of thoracic surgery at Tata Memorial Center, Mumbai. He is the convener of the National Cancer Grid, a large network of over 170 cancer centers in India. Also, he is a visiting professor at the Division of Cancer Studies, King's College London, and the Institute of Cancer Policy, King's Health Partners, London. Dr. Ramesh's primary clinical areas of interest include treatment of esophageal and lung cancers and minimally invasive surgeries. He also has a strong interest in clinical trial designs, surgical trials, comparative effectiveness research, and promoting collaborative research and cancer policy. Dr. Pramesh is highly committed to efforts towards reducing the inequities in cancer care and making cancer treatment accessible to all geographic regions and strata of society. With these words, please join me in welcoming Dr. C.S. Pramesh from Tata Memorial Hospital, Mumbai.
So now I would like to invite Dr. C.S. Pramesh to give his talk. Dr. Pramesh, you have 30 minutes for your talk, and then we will follow it up with questions and answers. So over to Dr. Pramesh.
Dr.
You are
Pramesh,
on mute.
muted. You're on mute, Dr. Pramesh.
Are you able to see my slides now?
Yes, see your slides and also hear you. Yeah.
Thank you. After 2 years, you'd think you'd get the tech right on, at least the audio and the video, but you never know. Anyway, thank you for the invitation and the opportunity to be part of this meeting today. And as Sudeep said, very humbled by the opportunity to participate in something to commemorate somebody who's been an extraordinary collaborator with the Tata Memorial family, Professor N.T. Banerjee. And again, it's a privilege to be here. So one of the risks of speaking after one of your own colleagues in the same institution is that there is so much in common. So I've had to do a very rapid revision of my slides in the last half an hour after Sudeep spoke, just to avoid overlap between what he spoke and what I did. And I'm hoping that I'm able to present some new thoughts for your discussion. So over the next half an hour, what I'll do is to speak about what we mean by digital health. And I do this deliberately, even in a forum like this, because this term is often misinterpreted in very different ways by different people, depending on the stakeholder who's involved. I'll move on to how can technology help with the health. Some key areas of digital health which have which have been promoted over the last decade or two. Some examples which have shown the successes of how digital health can help, and some of our own real life examples, and hopefully there should not be an overlap between what Sudeep spoke about and mine. But I'll end with some caveats because I do understand that I'm preaching to the converted here. We have champions of digital health, and it's often important and probably necessary to have an idea of some of the limitations as well. And then finally summarize. So as I understand digital health, it's a very broad and very interdisciplinary concept, which basically stems from an intersection between technology and healthcare. And I do know that this is a rather vague definition, but it still does some justice to encompass the breadth of what we discuss and what each of us interpret as digital health. And for this, we incorporate various combinations or standalone solutions with software, hardware, and services. And much of what I'm going to speak about over the next few minutes will deal with that. Before we move on to what digital health actually means, what the benefits are, and some examples, it's important to remind ourselves that there are several stakeholders involved in this entire exercise, and possibly remember that we need to keep patients at the center of everything that we do. But there is also a large a group of individuals, including physicians, researchers, application developers, technologists, medical device manufacturers, and distributors, who all play a very important part. And depending on which lens you look at this problem from, you have various solutions, not all of which might actually benefit the person we keep at the center of all of this. So with digital health technologies, these are some of the examples. I know this is a growing list. We start with electronic health records and medical records. I think COVID has brought the concept of telehealth and telemedicine very strongly into the forefront of what faces the consumer, in this case, the patient. And the revolution that we've had over the last decade or so with wearable devices, mobile health apps, and a growing emphasis on personalized medicine over the last 2 decades are all enabled by this concept of digital health. So there are various potential benefits of digital health systems. Again, I do realize that this is an extremely enlightened audience, but nevertheless, it's important to understand what these are, and so that we are able to speak the same language. The first and foremost benefit of digital health systems is that it makes healthcare very sustainable and agile. As you heard the previous speaker say, it has the potential to improve access and empowers patients in taking ownership of their own health, taking care of some of their own health-related problems, and improving the concept of shared decision making. It shifts the focus of health from healthcare to actually health promotion, prevention before care. And this is both to do with primary prevention, as you'll see with some of those devices that you have with mHealth applications, but also the prevention of complications in people who have a particular illness. And this is especially true for chronic diseases. When it comes to primary prevention, being able to diagnose certain conditions early might push the individual into more healthy lifestyles, thereby preventing the disease itself. And even in those who've had a disease diagnosed, so for example, with diabetes, there are several digital health solutions which ensure that the disease doesn't progress to a situation where the person ends up with retinopathy or nephropathy and any of those kind of complications. It redefines the patient-doctor relationship, and this is something that's not often realized when we come up with digital solutions. You have a wide spectrum of solutions, some of which actually alienate the patient-doctor relationship, but a truly beneficial digital health system should look at empowering patients and encouraging shared decision making, so that the doctor is in a sense empowered to have a more equal conversation with the patient, and completely redefines the traditional paternalistic relationship that we've had. And by doing so, it expands the reach of healthcare professionals, enabling them to focus on things which are truly requiring of their skill set, rather than get caught up in a lot of very routine, mundane, and often repetitive tasks. And it clearly optimizes clinician time. To me, the single most important aspect of digital health systems, and this is a filter which we probably need to run all our solutions through, and I don't think enough of that is being done in today's digital health world, is that it should reduce inequities in care rather than perpetuate them, as some digital solutions have actually ended up doing. And I think the education system that we've had thanks to the COVID lockdown and restrictions is a classic example of that. So online learning is something that should have democratized education, but on the contrary, thanks to the need for expensive, and by expensive, what is expensive to us, what is not expensive to us may well be expensive to the vast majority of the world's population. These are again aspects that we need to think about before we champion the successes of digital health systems. And I'll come back to this a little later in my talk. So who and how it can help is the entire gamut of stakeholders that I mentioned earlier. And I particularly like this cartoon, which is taken from the Ayushman Bharat digital mission, which looks at all possible stakeholders, but emphasizes something that is very fundamental to anything that is health related, which is to keep the general public and the patients at the center of everything that we do. Rather than find a solution and look for a problem for the solution to solve, so long as we again use this as a filter to decide where our priorities should be, I think digital solutions can be a lot better. And let's see how it can help with each of these stakeholders. With patients, as I mentioned earlier, it shifts the focus from care to health promotion, prevention, and above actual treatment. We've already seen the benefits of telehealth, how it enables patients a lot more than it otherwise would have been. Patients being the owners of their health records, the very real world issue of loss of health records, and especially with images, and the number of mobile health apps which have hit the market today. And again, I will add a word of caution here. Not all of them are regulated, not all of them are validated, and there is a need for caution when we look at these health apps. But nevertheless, these are solutions which are available and have transformed the way the general public as well as patients view digital health. For physicians, there are various examples of how it helps them. Decision support systems are only one of them. But again, I would remind you of the not so successful story of IBM Watson, which when it came out was touted to be the best thing that happened to physicians in sliced bread, but failed to live up to its promise for various reasons. Patient reported outcomes, again, bringing the focus of interventions onto the patient. Very often we look at scans, look at small reductions in scans as a measure of success of cancer treatment. But what really matters to patients are just two things. Will I live longer, and will I live better? And to answer the second question, patient reported outcomes are extremely important and an area where digital health can contribute quite significantly. We've heard previous speakers talk about remote monitoring, again, enabling access to the most rural of areas. And the other advantage that it could potentially have physicians, especially physicians working in busy clinical situations like what we face in India, is to have user-friendly data presentation which summarizes a patient's longitudinal history into a pictograph which can be readily accessed. For researchers, this is a goldmine. Data is the new oil. And this is a source of huge importance for researchers, and the importance of having open data systems which enable more and more researchers to mine data and come up with newer findings from what the original researchers envisioned is something that's extremely important. Having said that, the challenges of interoperability cannot be overlooked. And I would urge anyone working on digital health systems and solutions to look at this as an essential ingredient of what they build or develop in the long term. And again, coming back to linkages between different digital systems. For hospitals, in the administration, it improves systems. It offers the opportunity to see dashboards based on which processes and resources can be optimized so that the resources are put to the best possible utility and not in an ad hoc manner. For healthcare systems, again, digital health offers a lot of benefits, optimizes efficiencies. It's a huge resource for implementation science, bridging the gap between evidence and real life situations. And again, by promoting self-care for patients, possibly decreases the burden on the healthcare system itself. And for policymakers, it offers them the necessary data which is required to guide health policy. So if you were to look at many of the health policies in low middle income countries like India, they have failed because of the lack of the reliable data to support them. And anytime you speak to a policy maker or a researcher in countries like India, the constant lament that you hear from them is the lack of reliable quality data. And that's something that the digital health solution can plug. And it really helps them prioritize their next steps. So as I mentioned, one thing that the COVID pandemic taught us was the importance of telemedicine. Though it was forced upon us at the beginning, thanks to the restrictions, we have grown to realize the benefits of telemedicine by improving patient engagement, satisfaction. It improves access to healthcare, to expert opinions, to reduce the costs of healthcare, and overall bring better treatment outcomes. So going by what the market is looking at, it is expected to grow at a CAGR of 26.6% and growing from 90 billion US dollars to just under 300 billion US dollars in just over 5 years, clearly demonstrating that telehealth and telemedicine is here to stay. M-Health is again something that there's a lot of been a lot of work on. Wearables have transformed the way we use devices. looking at the points like heart rate variability, pulse oximeters, which came in very handy during the COVID pandemic, ECG monitoring, and I'll show you an example subsequently, continuous glucose monitoring. And this is coming back to what I mentioned earlier, both with primary prevention of diseases like diabetes, as well as prevention of the complications of diabetes like retinopathy and nephropathy by continuous glucose monitoring. And by using these apps and mobile technology, it actually improves the access to healthcare support and monitoring, which otherwise would not have been available for the majority of users. So I'll give you this example of the Apple Watch, a very nice study and a kind of a revolution which came out 5 years back in collaboration with Stanford medicine researchers who looked at whether a wearable technology, in this case the Apple Watch, could help detect atrial fibrillation, a form of cardiac arrhythmia, earlier than what it would have otherwise have been detected on a clinical basis. And what this study clearly showed was that the Apple Watch and the software integrated with it and the app that it was linked to could actually detect irregular rhythm suggestive of atrial fibrillation much before patients realized it, thereby enabling much earlier care being offered to these patients. I'll come back to this a little later when I point out the caveats of what we should think about when it comes to digital health solutions. This is another remarkable success story in mHealth, looking at asthma management. So there is this really small sensor which gets attached to most of the conventional inhalers which patients with asthma regularly use. And this sensor and the app that is linked to the sensor gets multiple data inputs, not just from the sensor itself by way of breath volume and gas analysis, but also from routine weather reports, which the app is able to extract from other data sources. And with a combination of this data, it's actually able to predict the risk of developing an asthmatic attack and go to the point of suggesting which inhaler to use and what dose to use and at what frequency. So something which is completely in the patient's hand, empowers the patient remarkably, and without having to access a complex healthcare system, helps with something which is a very true real life problem. Many previous speakers have spoken about artificial intelligence, the ability to augment human decision making by automation and speeding up what was otherwise repetitive or labor intensive tasks is at the heart of what AI is all about. But patient monitoring tools where data collection and treatment of patients is based on real-time reports rather than one-time testing of data is something that has truly revolutionized several areas of health. And this new exciting concept of digital twins, which acts as a model for medical devices and for patients, which would in a much earlier than a beta version show how devices and would work when in actual conditions and especially in relation to patients using them. Just this is the tip of the iceberg as far as AI is concerned, and there's much more to go. So a lot of things have been spoken about big data. And just a very layman's definition of this would be data that's too vast or complex to be understood by traditional means of data processing, bringing this very new brave world of machine learning algorithms, probably not so new anymore, but nevertheless, we are learning as we go. And this the importance that data scientists currently have in analyzing this kind of data. And as you can see on the cartoon on the right, the sources of these big data are very diverse, some of them being extracted passively through existing data systems and some of them being inputted actively using other records. And if you look at most of these, for example, smartphones, wearable devices, electronic health records, these are all passive ways of extracting data, which all goes into this big pool from which meaningful analysis can be made. The problems about big data is that are the three V's. The first V being extraordinarily high volume. The second being that it moves at very high velocity and it spans the breadth of the health industry's pretty massive digital universe. But the problem also exists that because it is derived from many sources and the lack of standards in data with many of these sources, including imaging devices, it is highly variable. And the result is that it becomes fairly complex to merge these big healthcare data into conventional databases and make sense out of them without using big data or AI. And therefore, it is quite challenging to process. I don't want to go into too much depth about the possible applications of big data, but if you look at all the areas of health and healthcare, starting from preventive medicine to diagnostics to precision medicine, research, adverse event monitoring, reduction of costs, and population health, there are several examples that we've had from big data that very easily plug into these problems, which are very real life problems as well. And going into more granular data, looking at medical imaging, going to as mundane tasks as improving supply chains, which came into the forefront with the COVID pandemic when there was a universal shortage of various drugs, personal protective equipment, masks, and so on. And going on to other applications like self-harm prevention, mental health, smart staffing of healthcare providers, reducing fraud, especially with insurance claims, and so on. Augmented reality, I believe, is something that's not been exploited as much as it should be, though it forms a very integral part of digital health. Learning systems where augmented reality has a huge role to play still haven't matured to the point of replacing real life learning. And to me, this is a shame because every pilot who learns to be a pilot goes through extraordinary simulation exercises before they actually fly a plane on their own. Whereas with medicine and healthcare, most medical students learn on patients rather than using simulators. And this is something that has been hugely underused and undervalued as far as learning processes are concerned. So I'll come to the final half of my talk, which is to focus on what should we really do to have impact in the real world. And to me, there is this huge disconnect between what most of the digital health community is working on and what is actually truly required in the real world. And it comes down to this issue of disparities and inequality we have in the world. And I'll take a couple of minutes to explain what I mean by this. If you look at the Human Development Index, there's plenty to be happy about. If you look at the last 150 years, starting from 1570, there's been remarkable progress practically in every region of the world. But if we were to look at some of these countries, and if you were to exclude the OECD countries and go down to something like Sub-Saharan Africa, Latin America, Asia, excluding Japan and China, you see that the increments in the Human Development Index haven't been dramatic. Similarly, for GDP per capita, if you were to look at countries in North America, Australia, New Zealand, and Western Europe, you see much more dramatic increases in GDP as compared to other areas like Sub-Saharan Africa, Southeast Asia, Latin America, and Middle East, and so on. This is a very sobering report, and for those of you who have not read this, I will earnestly urge you to go through this World Inequality Report, which came a month or two back, which looks at global income and wealth inequality, and this is 2021 data. So what it effectively means is that the top 10% of the world, of the top richest 10% of the world, is responsible for 52% of the global income, whereas the bottom 50% account for just 8.5% of the world income. It is even more stark when it comes to wealth. The top 10% of the world owns 76% of the global wealth, and the bottom 50% own 2% of the global wealth. If you were to look at the concentration of capital and wealth inequality across the world, you realize that the discrepancy between the richest and the poorest actually gets worse as the income level of the country goes lower, which means that in countries like Latin America, MENA, Russia, Central Asia, Sub-Saharan Africa, the discrepancy between the richest and the world actually widens compared to countries in Europe and other parts of Asia. So clearly showing that inequality is real, and even within low middle income countries, there is huge inequalities. And again, this is a graphical representation of the bottom 50, top 10 income gaps across the world. So clearly showing that inequality. So what I'm talking about is not the top 10% who have access to the best solutions in the world, but the bottom 50% on whom I strongly believe that digital health solutions should be focused upon. So I'll show you a few examples of some real world situations where we decided to focus within the Tata Memorial and the National Cancer Grid on where digital health solutions. And these solutions might look rudimentary and very primitive to you in comparison to some of the examples that you saw earlier on, both by in my own talk as well as by previous speakers. But when you look at impact, that is what we need to measure as a true measure of whether a digital health solution is important or not. So to me, looking at real world problems, very clear problem definition, offering realistic solutions, and looking at the top 10 versus the bottom 50%. And I think Dr. Soumya, when you look at the cancer moonshot, which was launched with great fanfare by several organizations, including MD Anderson, the most recent by President Biden of the United States. What I would urge digital health to look at is while you continue to look for moonshots, also look at earth shots, which is looking at real life, real world problems and finding solutions to them. So some of the initiatives that we've been involved in within the National Cancer Grid has been to look at quality assurance in surgical pathology, which is looking at web-enabled services where quality assurance and a system of accreditation of member centers within the National Cancer Grid is enabled, with over 150 centers participating in this quality assurance program. So by doing a very simple intervention of improving the quality of pathology reporting, you're automatically transforming the care that you offer to hundreds of thousands of patients across the length and breadth of the country. We've more recently expanded this quality assurance program to include molecular pathology as well. The next point that I want to talk about is online learning. We have the NCG Quality Improvement Program, which is a blended learning program. Learning is something that most people don't think about when it comes to digital health, and this is something that I strongly urge all of you to think, not just by blended learning and online learning courses. We also have simulations, we have augmented reality to supplement these, mimicking a real life situation much better than what we otherwise would. Sudeep did speak briefly about the expert opinion service. This is again a web-enabled service from the Tata Memorial and the National Cancer Grid, where we offer expert opinion service which is based both on AI, based on available evidence collated from the top trials, clinical trials in the world, but also looks at expert oncologists' opinions to further refine their choices. Tumor boards, which started much before COVID, though this became popular in many parts of the world during COVID. We started 6 or 7 years back. We've had over 600 tumor boards which have been conducted so far within the National Cancer Grid, which not only benefits the patient whose clinical case is getting discussed, but also serves as a continuing medical education program for those who are involved in participating in this. Looking at very simple solutions like collating library sources through a discovery tool, making it very searchable, thereby democratizing cancer education across the National Cancer Grid members. A massive open online course, which we run under the ncgeducation.in portal, where we collate educational material from several of the NCG centers and thereby help disseminate this, again, democratizing medical education. So this is an effort that we are fairly proud of. This is something which we started as a proof of concept working on patient health records and interoperability 2 or 3 years back, where we looked at a very simple pilot project, which we were able to prove that with 3 different electronic medical record systems, we were able to aggregate using mock patient data and patient consent management, getting it into a gateway where we enabled the very different data sources to be combined into one source. And though this was not converted into a format which made it analyzable, it nevertheless was one step forward in aggregating disparate patient health records into one service. And this has now gone on to be the heart of what the National Digital Health Mission is working towards and developing further. I did mention to you about the EQUIC program, which is the quality assurance program. If you look at the impact that we've had, we've trained 32 teams in quality improvement across the country with over 200 professionals who have utilized this. And based on this, we've had 64 of these professionals being certified as quality improvement leaders, and thereby making a exponential increase in the value that quality is done across the National Cancer Grid. And we do this in collaboration with the Stanford Medicine Group. Impact Head Neck is another integrated module on palliative care. Again, dissemination of palliative care knowledge and information across various professionals. Before I end, I want to focus a bit on the problems, and I'll take you through a few of them just to illustrate the fact that digital health is all not rosy, and we need to run it through several filters before we embrace this as the next best thing. We do realize that health data is very clunky, and the fact that it comes from very varying sources, many of whom do not have standards of collecting data, does make this very difficult to combine into a common database. And this is probably something that industry, device manufacturers and regulators probably should put some thought into, to have uniformity of data creation as well as collation. The lack of quality data and the privacy concerns are aspects which many previous speakers have already spoken about, but again, important to realize that these are issues that we need to address. The lack of common standards when it comes to deriving or accessing data from devices, the interoperability between these devices as well as electronic medical records, the validation, and I'll come to that with the final example a bit later, where often the technology overtakes the science and we often compromise the rigid structure of how we do clinical trials for the sake of expediency, and we allow surrogate markers which may not necessarily be true in the real life world. And I think in some areas we need to be conscious of the fact that tech may actually deepen disparities instead of reducing them, which was the original goal. And I'm reminded of this quote which the chief scientist at WHO, Dr. Soumya Swaminathan, made about digital technology. She said, if digital technologies are to be sustained and integrated into health systems, they must be able to demonstrate long-term improvements over the traditional ways of delivering health services. So for all of us who are converts to digital health, this might seem a very rudimentary and a very basic comment to make, but I think it goes at the heart of what public health systems are all about. It's no longer about the tech. It's no longer about whether there are incremental improvements in the technology, but unless you have an impact on the real world, these digital health solutions are not really improvements. I'll come back to this example, which actually got published in the New England Journal of Medicine, the Apple Watch study. Again, in collaboration between Apple, it was funded by Apple, run by the Stanford medicine researchers. Over 400,000 participants followed up over 8 months with a median of 117 days, of which 0.5% received notifications, which meant that they had some abnormality in their heart rhythm, which they received a notification for. And there was 84% concordance with atrial fibrillation, which is a potentially life-threatening illness. So clearly showing that even with very strong technology, you need to validate them in the real world before adopting them as routine. But even after such a story, we very soon, within 2 to 3 years of the study getting published in the New England Journal, we started getting warning signals where some limitations were identified, which are not identified in the original study. Another study which looked at whether people under the age of 55, which is actually the target age, right? I mean, these are the people who are most likely to wear these devices. And in those, it failed much more than it did in those above the age of 55. And in people younger than 55, the Apple Watch positive predictive value was just under 20%. Though 84% concordance was achieved by the original study, the real life situation showed that in people younger than 55, it was a much lower positive predictive value. And again, newer studies which show that when your heart rate is over 120, which is a more risky kind of atrial fibrillation, the Apple Watch just can't catch it. So not only is the validation process important and needs to be robust, but following them up in the real world also is extremely important. And this is something that I will harp upon because this is something which is not done when most newer technologies are adopted in the real world. So this is my final slide. To summarize, I'm a big champion of digital health. It has exciting possibilities to practically all stakeholders. It truly has the potential to democratize health and healthcare. It benefits or has again the potential to benefit all the stakeholders involved in health, but quality, validation and access should be the filters that we run every single advance which we promote under digital health. And if it passes these three filters, it's probably ready for prime time. And the most exciting part about digital health to me is that it can, for many countries, especially the low middle income countries, it can help leapfrog an entire generation of medical advances, which high income countries have painfully gone through. And this is the exciting potential, which to me, digital health is clearly the science of tomorrow. I'll stop with this for now, and I'm happy to take any questions.
Thank you, Dr. Pramesh, for a very interesting and informative talk about digital health and the recent advances in digital health. Questions? Any questions from the audience?
As we wait for others to ask questions, I'm always ready with some. So could I go ahead, Sudeep? Yes, yes. Thanks, Dr. Pramesh, for an excellent talk again. It's always a delight hearing you. Just want a more general question and more general guidance on how, based on your NCG, especially the Equip India initiative. How do you see the different entities like institutes of technology, KCDH specifically, right? You have NGOs on the other hand, foundations, Bill and Melinda Gates Foundation. There are many other foundations. And there's government, central and state. Then there are hospitals, and I'm kind of mixing the frontline workers, ASHA workers with hospitals, but yes, you can also think of them as also two different buckets. And finally, the software industry, the professionals, right? And also consortiums in that on that front. How do they play complementary roles? I think it's very important to identify this, maybe have some discussion across them, given that NCG in some sense has also been a seed for ABDM, right? They've taken it as a strong precedent, but isn't it an important thing to discuss across the board and identify the roles they should be playing?
Most certainly, and I think right from about 2 to 3 years after the NCG was initiated, we did realize this, the importance of doing so. So while, to be honest, when we started the NCG, it was meant to be only cancer centers, and at the beginning only government cancer centers. We have rapidly evolved over the last 10 years. So we went on to include private healthcare providers as well, because we realized that a large part of India's cancer management actually happens in private sector. Then we moved on to include research institutions. So IIT Bombay, for example, is a member of the National Cancer Grid. There are several standalone research institutions which are part of the National Cancer Grid, and I'm hopeful that KCDH, also independent of the IITB, will play an important role in the way the NCG evolves in digital health over the next decade or so. And again, NGOs, our partnership with Ayushman Bharat, our partnership with the DBT, all of this emphasize that it is so no single player, whether it is a healthcare provider, a healthcare professional, government, can reach success on its own. And I'm very often reminded of this, and I do use this slide very often in my talks. The teamwork that happens during a Formula One pit stop. So Formula One pit stop takes about 2.3 seconds, and over the course of 2.3 seconds, you turn over 4 tires remove 4 tires, put in 4 tires. You can actually have the nose changed of a Formula One car, and there's this huge group of around 15 to 20 people hovering around the car, each playing their own single role. And to me, that is the essence of what healthcare should be all about. And if we are able to crack this, the fact that we work cohesively with these various stakeholders, without stepping on each other's toes, each of them realizing their own role in it and playing it to perfection, I think there are no boundaries to where we will reach, and this is something that I would very strongly urge.
Thanks.
Thank you. I would like to ask a question. So I know this cancer treatment is like lot of follow-up treatment. People have to come back, otherwise there's a chance of it recurring and everything. So with this virtual era, I mean, do you think it is going to be easier? I mean, little bit ease this follow-up, getting appointments, people will come back.
So absolutely, I think thanks to COVID, so there was this huge reluctance amongst patients as well as providers to rely purely on a virtual follow-up system. What if I miss something which the patient has? What if there is some finding which, because I have not examined the patient, I will miss out? But I think to a large extent, it has been laid to rest by the fact that COVID forced this upon us. And now we find patients and providers being far more comfortable with using these tools much more than it ever was. So I think it's here to stay, and it is actually a very good sign as far as healthcare access is concerned, because you no longer have the need to travel long distances to be able to access expert care. And this is something that's very, very important.
So can we say that the indirect healthcare cost will go down due to this?
So I think at least with telemedicine, it's very clear that indirect health costs will go down. What we need some more confidence and clarity upon is the fact that outcomes are not compromised. And I think these are very specific to each situation. So for example, if you had someone with very advanced metastatic cancer, something getting missed on that follow-up, probably it doesn't mean that much. But if somebody has a potentially life-threatening complication happening which requires acute care, if that gets missed, then I think that's something that we need to be conscious about. So continuing to collect data on all of these interventions is very important, as we saw with the Apple Watch example, even if it's been proven in robust studies.
Thank you. I have one more question. I have read that in tuberculosis there is a discrimination in men and women healthcare. Like it's like a stigma for women, especially unmarried women. So in Indian cancer healthcare, is there any kind of such discrimination, do you think?
So in some situations, yes. So when we looked at our own pediatric cancer data, we found that more boys were getting treated as compared to girls. And this is contrary to most of the data available in other societies globally, where where girls are actually a higher number to get treated than the boys, primarily because there are some cancers which are more common in them. And to some extent it does happen. But again, there's been some very real world solutions that we found to this by creating an environment in pediatric care which ensures that patients don't lose their livelihood, parents don't lose their livelihood, children don't, the costs of cancer care for children doesn't bankrupt the parent. And this is thanks to some of the NGOs that we work with. For example, St. Jude's is a classic example, who provide accommodation services, education for students, education for the children, job opportunities for the parents, and so on, thereby creating a holistic solution wherein treatment abandonment is reduced. And we've been able to flip this, the ratio of girls to boys being treated to almost reach a neutral level.
Thank you. Yeah.
Not digital health, but a very effective solution.
Yes, yes. Thank you. Yeah. Any more questions?
I don't have a question. I just wanted to comment that wonderful session. Nice to meet you, Dr. Pramesh, online, and look forward to working with you. Thank you.
Thank you, Dr. Prasad. Thank you very much, Dr. Prasad.
So I can see a raised hand from Aniruddha, Mr. Aniruddha. Do you want to ask a question?
Yes, ma'am. I'm not able to find the chat button, so I will ask it on.
Yeah, maybe you can increase your volume. It's yeah.
Yeah, good morning, sir. Nice talk. I just wanted to ask, there are few cancers which are very prevalent in some parts of the country, and very few centers treat those type of cancer. And in other parts of country, it might not be so. So you won't even get a single case of that cancer. So how does one envision the expertise of reporting those cancers or treating and diagnosis those type of cancers in some part of country, and how does AI play a role in that, and the role of NCC in that?
Thank you. That's a really good question, and it goes to the heart of what we describe as a hub and spoke or a distributed model of cancer care. So what we are promoting is the fact that most of the common cancers and the less complicated cancers should be treated close to home. So this involves probably about 80% of all cancers. So a patient with a very common cancer or a cancer which has a fairly straightforward treatment solution offered to the patient should have care without having to travel long distances. On the other hand, there are some of these rarer cancers and more complicated cancers where we advocate a more centralized approach, the exact opposite of what I described earlier, which was a decentralized approach, which looks at creating these centers of excellence for rare cancers and complicated treatments. And we encourage that patients, which will then only form 20% of all of India's cancers, going to these centers of excellence, which means that the expertise, the infrastructure, the equipment that is needed to treat these cancers are localized in a particular central area. And it negates the need for creating multiple such centers in all parts of the country. So I'll take this example of proton therapy, which is an exciting new method of radiation therapy, gives highly precise, with very high doses of radiation. And this is most useful for children with brain tumors. So you must understand, and the cost of this equipment, of one equipment, is close to 400 crores of Indian rupees. So it is clearly not possible to have hundreds of these proton therapy machines across the country. So what we advocate here is a more central form of treatment where all children with pediatric tumors, which is actually a pretty rare disease as far as cancers go, are referred to these centers of excellence, and thereby you use these resources more optimally.
Sir, but then we just discussed that AI would make it a common playing ground for diagnosing these type of cancer. So it would be easier to diagnose these types of cancer. So would
Right.
that not lead to a decentralized approach in treating these rare type of cancers? So sitting in Bombay, if I'm seeing that cancer, I would be equally competent enough as one in Chennai or in Guwahati for that matter.
In a number of situations, yes, where it doesn't depend upon the actual expertise. If it is a skill-based situation. So, for example, for complex surgery, for example, we have still not reached the phase where you have virtual surgery being performed across across large distances. But whereas when it comes to diagnostics, this is certainly something that can happen. Using AI, using diagnostic tools with AI, with pathology, you can certainly make this available locally. But again, coming back to this situation of infrastructure. So if you needed a patient to be treated with proton therapy, this is not something that you could do in 100 centers across. So it would be a nuanced answer to that. For certain diagnostics situations where the treatment can be offered close, but the diagnostic tools are not available everywhere, we certainly could leverage AI. Having said that, I am aware of some newer advances, even with remote surgery. So it's not too far-fetched, but it's not ready for prime time just yet.
Yeah. Okay. Okay. Thank you.
Any more questions? Okay, so thank you, Dr. Pramesh, for the talk. Now I would like to invite Professor Ganesh Ramakrishnan, our PIC, to give the vote of thanks.
Thanks again, Dr. Pramesh. Thanks, Professor Sudeep Gupta, Mr. Girish Raghvan, Dr. Pramesh, for very enlightening talks. I think this was a very enriching session overall. And it's also interesting that we've kind of completed this in record time. We've completed before time. This also speaks volumes of how valuable the time of our doctors are. So we should all learn to value that time. I'd also like to invite the audience to a couple of sessions we're going to have later in the day. In fact, right now we're going to have some student posters. I'm just going to bring up this slide. So we'll have poster competition by students until 12:10 p.m. Followed by industry talks. At 12:10 we'll have Mr. Nipun Virmani, co-founder RIA, and then these are shorter talks. And then the industry talk 2 by Mr. Shashank Chilamkurti, founding member of Cure.ai. We'll again, like we had the morning keynote talks, we'll have evening keynote talks at 7 and 8 respectively by Professor Bhramar Mukherjee at 7, and then by Dr. Nitish Thakur at 8. Between 5 and 7:20 p.m. we'll have spotlights on research projects funded by KCDH. Several of them are collaborations with Tata Memorial Hospital and several other reputed hospitals. There are 14 projects, 10 minutes each. So with that note, I would like to thank again the speakers. I look forward to continued interaction of this sort. Thanks, Dr. Pramesh. Thanks, Dr. Sudeep, and thanks, Girish.
Thank you, Ganesh. So now we need to join a new link or just continue on this link?
Link will be same. Link will remain same.
Okay, okay.
So I think our poster presenters are also with us. Am I right? Abu? One is Abu and another is Abhilash. Yeah. Okay. So if
should we follow
Dr.
time
Nirmal is also ready, then we can start right now.
Yeah, we can start.
Yeah, Dr. Nirmal, you are there?
Am I audible?
Yeah, you are audible. And our presenters are also with us, so we can start that poster competition session right now. Is that okay, participants? Abu and Abhilash?
I think that'll be great. We can get started right now. We'll have a little more time for interaction.
So I request to Dr. Nirmal to proceed this session. Thank you. Over to you, Dr. Nirmal.
Dr. Rashmi, like, or is there a sequence like Abhilash is going first or Abu?
Abu is going to first, followed by Abhilash.
Okay. So is Abu here?